Hello there, Mr. Sutton bringing you the AB Calculus 410 homework solutions on derivatives of inverses. For number 1, we're given a table of values for f and f prime of x. If f inverse is the inverse function of f, what is the value of the derivative of f inverse of 11? So for this, we're going to use the inverse derivative formula. So we're going to say f inverse prime of 11 equals 1 over f prime of f inverse of 11. So 1 over the derivative, the original function derivative of the inverse value of whatever you're plugging in here. So we've got f inverse of 11. That's the x value that gives you an output of 11. So looking in my output column, the f of x column, for 11, I need an input of x equals 10. So this is really 1 over f prime of 10. And then f prime of 10, we just have to look further along in this row to get negative 11. So this then is going to be 1 over negative 11. For number 2, f is a differentiable function with these function values and this derivative value. The function g is differentiable and g equals f inverse of x. So g and f are inverses. We want to know the value of g prime of negative 10. So we're going to use the inverse formula for this. G prime of negative 10 is going to equal 1 over f prime of g of negative 10. And then g of negative 10, well, that's just the x value that gives you an output of negative 10 when you plug it into the f function. So let's see here. Looking at an output of negative 10, we see over here f of 12 gives us negative 10 as an output. So that means g of negative 10 is really this 12 that's being plugged into the f function. So we've got 1 over f prime of 12. And then f prime of 12, that one's a little more straightforward. They gave that to us here. That's 7. So 1 over 7. For number 3, we've got an f function here, cubic function, and g is the inverse of f. Given that f of 2 equals negative 16, what's the value of g prime of negative 16? So we're basically asking for the value of the derivative of the inverse of this f function at the value negative 16. So for this, I'm going to use my inverse derivative formula. So I'll say g prime of negative 16 equals 1 over f prime of g of negative 16. Like so. At this point, we could either plug something in for g of negative 16, or we could calculate what f prime is actually doing in terms of derivatives. I'm going to take the derivative of f, but you could do what I'm about to do in either order. So derivative of f, that's going to be negative 9 something squared plus 8. Or actually no plus 8, because that's going away. That's a constant. So just negative 9 times g of negative 16 squared. Like so. So this g of negative 16 is just functioning like an x up here. Next, what is g of negative 16? Well, that's the input I would have to plug into the f function to get an output of negative 16. Taking a look over here, the only function value they gave us is when I plug 2 into f, I get back negative 16. That means g of negative 16 must be this input of 2. So I can just rewrite this as 1 over negative 9 times 2 squared. So that's negative 9 times 4, so 1 over negative 36. For number 4, we've got this f function, and g is the inverse of f. Given that f of 0 is 2, what's the value of g prime of 2? So we're looking for the inverse derivative of this f function at the value 2. So let me use my inverse formula. I can say g prime of 2 equals 1 over f prime of g of 2, like so. All right, well, let me calculate f prime. So that's going to be 9 minus, let's see, this is going to be e to the 5x times 5. So 9 minus 5 times e to the 5 times something, right? Whatever we're plugging in. So in this case, that something is g of 2. So I've got 1 over 9 minus 5e to the 5 times g of 2. Now we have to figure out g of 2, and you could have done that earlier, but I chose to wait until here for whatever reason. So g of 2, that's going to be the input that I have to plug into f in order to get an output of 2. Well, my output of 2 is over here. The input for f on that is 0, so g of 2 then must be this input of 0. So let me just replace g of 2 with 0 here. So this is going to just be e to the 0, which is just 1. So we're basically doing 9 minus 5, which comes out to 1 over 4. For number 5, f is a differentiable function with the following function values and derivative values. Function g is differentiable, and we're saying that g is the inverse of f. So what's the value of g prime of negative 1? So since I want the derivative of an inverse, I'm going to use the derivative inverse formula. We can say g prime of negative 1 equals 1 over f prime of g of 1. Well, what's g of 1? That's the input I had to plug into the f function to get an output of negative 1. Taking a look at my f function values here, we see that we get an output of negative 1 when the input is negative 11. So g of negative 1 then is this negative 11. So I'm doing 1 over f prime of negative 11 then. Well, what is f prime of negative 11? They tell us right here. It's positive 11. How about that? So this is just 1 over positive 11 then. Final answer. For this problem, we have a table with selected values of h and its derivative h prime, and we're also given g is a differentiable function such that h of g of x equals x. Based off this, we want to know the value of g prime of 7. So we have to decode this a little bit. This h of g of x equals x business, they're basically telling us that h and g are inverses. So g is the inverse of h. Since we're trying to take the derivative of an inverse, we need the inverse derivative formula. So we can say that g prime of 7 is going to equal 1 over h prime of g of 7. And if we write this formula out now, we just have to go to the table to figure out these values. G of 7, that's going to be the value that's going to be the x value I have to plug into h to get an output of 7. So looking in my table here, when I get an output of 7 for the h function, it looks like I plugged in 3 to get 7. So that means that g of 7 is going to be this input of 3. So I've got 1 over h prime of 3. And now h prime of 3, well, they told us that too, that's going to be 5. So this comes out to 1/5. For number 7, f and g are functions that are differentiable everywhere, and g is the inverse of f. And we're given these different values. Based off of this, we want to know what g prime of negative 2 is. So if I'm looking for the derivative of an inverse, this really boils down to whether or not you know the derivative inverse formula. We can write this as g prime of negative 2 equals 1 over f prime of g of negative 2. And now we just have to calculate g of negative 2 and then f prime of whatever that comes out to. G of negative 2, they were actually very nice here. They gave it to you right here. They didn't even make you work backwards. G of negative 2 is 5. So this is just then 1 over f prime of 5. Well, f prime of 5, they also gave you that exact thing. That's negative 1/2. So if we do 1 divided by negative 1/2, that comes out to negative 2. Choice E. On number 8, we've got this table with selected values of f. If g is the inverse of f, what's the value of g prime of 3? So for this, we're going to use the inverse derivative formula. G prime of 3 is going to equal 1 over f prime of g of 3. And we'll make sure we plug 3 in there as well. G of 3, that is going to be the input to the f function that gives me an output of 3. So looking in my table here, in the f of x column, I get an output of 3 when the input is 1. So that means g of 3 is 1. And then f prime of 1, I'm just going to look over to the far side of that same row. That's going to be 4. So 1 over 4, choice B, final answer. On number 9, f is this polynomial function, and g is the inverse of f. And we have g of 3 equals 1. We want to know the value of g prime of 3. So one way to do this would be to try to calculate the inverse of this, which is going to be a huge mess, if not impossible because of this squared term. Another way to do it is to just use the inverse formula. G prime of 3 equals 1 over f prime of g of 3. And we know that f prime in general is just going to be 3x squared plus 2x plus 1. We'll just write that over here so we don't lose it. G of 3, they actually told us right here, is 1. So we've got then 1 over 3 times 1 squared plus 2 times 1 plus 1. That's going to be 1 over, let's see, 6, which comes out to choice C. For number 10, f's a differentiable function with the following function values and derivative values. And g is the inverse of f when all is said and done here. We want to know the value of g prime of 3. So easiest way to do this is use that inverse derivative formula. G prime of 3 equals 1 over f prime of g of 3. And now what is g of 3? Well, g of 3 in general, this is going to be the thing you have to plug into the f function to get an output of 3. So taking a look at our f function values, I get an output of 3 on the f function when I use an input of 6. So g of 3 then is going to be this input of 6. So we're doing f prime of 6 down here. And then f prime of 6, they gave us that directly. That's going to be negative 2. So we have 1 over negative 2, which comes out to choice A. For number 11, we've got this polynomial function for f. G is the inverse of f, and given that f of 0 is 1, we want to know the value of g prime of 1. If we're taking the derivative of an inverse, we'll use our inverse derivative formula. So we can say g prime of 1 equals 1 over f prime of g of 1. And f prime, that's just going to be, let's see, we've got 3 times all this stuff squared times a tail of 2. So altogether 6, parentheses 2x plus 1 quantity squared. And then g of 1, well, what is g of 1? That is the input to the f function that gives me an output of 1. So looking at the output of 1 up here, my input for the f function was 0. So then g of 1 is going to be 0. So I'm doing 1 over 6 times 2 times 0 plus 1 squared. And then let's see here. We've got 1 squared is just 1 times 6 is 6. So 1 over 6 when the dust settles, choice D. For number 12, we've got this table of all these values for f on an f and a g and an f prime function. We want to know if g is the inverse function for f, what's the value of g prime of 4? Quickest way to get started is just use our inverse formula. G prime of 4 equals 1 over f prime of g of 4. And these are things we can just look up in our table now. G of 4, looking in the g column here, when I plug in 4, I get a g value of negative 2. So this is 1 over f prime of negative 2. And then f prime of negative 2, let's see, here's negative 2, here's f prime, that comes out to 4. So we have 1/4, choice D. For number 13, we're given two functions, f and g, that are differentiable, and they're given those functions some certain values in this table, along with some derivative values. And then they throw this h function at us, which is given by f of g of x minus 6, the composition of those. So given this, part A is asking us to explain why there must be a value r between 1 and 3, such that h of r equals negative 5. Whenever you're asked to show that a y value exists on a certain interval, you should use the intermediate value theorem. In order to use this theorem, at least on an open response question where you want to get full credit for your work, you need to show two things. The first condition is you need to show that this function is continuous on the interval you're looking at, namely 1 to 3. You also need to show that the y value you're looking for, negative 5, is between h of 1 and h of 3, the starting and the ending y values. If you have continuity and this is between the two y values, then you're guaranteed to hit it at some point on this interval. So let's establish continuity first. Do we know that this is continuous? We do. How do we know that? Well, they told us f and g are differentiable, which includes continuity, and we're just doing a composition of these and subtracting 6, which isn't going to affect anything anyway. So because f and g are differentiable, their composition has to be differentiable, and that means their composition, H, has to also be continuous. Now, if you don't believe me on this composition being differentiable bit, just think about this real quick. If G is differentiable, which they said it is, that means that it's continuous, and that means that it's defined everywhere. So no matter what I plug in for X, G is going to give me a real number back. F. Where is F differentiable? Well, F is differentiable for all real numbers. So if I'm always plugging real numbers in here, F is going to be differentiable no matter what I throw at it. So that's the intuition behind why this is going to be a continuous function. How about the y values? So if we take h of 1, that's going to be f of g of 1 minus 6. And we have to do this in a couple steps here. G of 1 we have to look up in our table. G of 1 is going to be 2, so this is f of 2 minus 6. And f of 2, that's going to be 9. So 9 minus 6 gives us 3. So then at this point, we're looking for something less than negative 5 when we plug 3 into the h function. Let's see if we get it. So we've got f of g of 3 minus 6. G of 3, that's going to be 4, so we're doing f of 4 minus 6. And then f of 4, that's going to be negative 1. Negative 1 minus 6 comes out to negative 7. And now for the justification. Since h is continuous, you got to mention continuity, and negative 5 is between those beginning and ending y values, negative 7 and 3, the intermediate value theorem states that there's an r between x equals 1 and x equals 3 such that this r equals negative 5.
For this problem part, they want us to explain why there has to be a c value between 1 and 3 such that h prime of c equals negative 5. Okay, so when we're talking about the instantaneous rate of change of a function equaling a certain value, and we have an interval to work with, the mean value theorem is our friend. So to use the mean value theorem, we're going to have to establish that the h function is differentiable, and we also have to establish that the average rate of change of this function over the interval from 1 to 3 is, in fact, negative 5. So to set that up, let's find our average rate of change first. So that's going to be h of 3 minus h of 1 over 3 minus 1. And I think we can agree that 3 minus 1 is 2, so the denominator, we'll do that first. And then actually back in part A, we actually found h of 3 and h of 1 already, so we don't really have to show anything on that beyond writing negative 7 for h of 3. And this h of 1 ended up being 3, so this is minus 3 then. So we have minus 10 over 2, which comes out to negative 5. Okay, so we've got our average rate of change. But we're not out of the woods yet. We need to write a coherent justification sentence. So we're going to start with the premise that h is differentiable. Now, we don't have to prove this again because we already proved it back in part A by saying that it was h was a composition of f and g, both of which are differentiable. So again, if the functions that you're composing, plugging into each other, are differentiable, the function that results is differentiable. So since h is differentiable, and the average rate of change, which we just found, over 1 comma 3 is negative 5, the MVT guarantees a c value on 1 to 3, the open interval 1 to 3, such that h prime of c equals negative 5.
For number 13, part D, if g inverse is the inverse function of g, we want an equation for the line tangent to the graph of y equals g inverse of x at x equals 2. So tangent lines, we need 3 things: an x value, a y value, and a slope. They gave us the x value, so we're going to use that to help us find the slope. We need to find g inverse prime of negative 2, or rather positive 2. So g inverse prime of 2, that's going to be 1 over g prime of g inverse of 2. G inverse of 2, that's the input to the g function when I get an output of 2. Looking up my output of 2 in my g column, that happens at an input of 1. So we're just doing 1 over g prime of 1. Well, g prime of 1, that's going to be 5. So this is just 1/5. So that'll get us a little bit of the way there. We still need an x and a y value, though. Well, they actually gave us the x value too. To get the y value, we just need to plug this into the g inverse function. So if I do g inverse of 2, I'm asking what did I have to plug into the g function to get an output of 2? And oh wait, we actually already did that, didn't we? It was 1. So then, plug in all this in, we're going to have y minus this output of 1 equals our slope of 1/5, parentheses x minus this input of 2.